So good afternoon, everybody. I think it's time we start. First off, I would like to welcome our amazing speakers from Accenture. They will be giving the talk today for our Data Science Realm meetup. As always, we encourage you all to participate in the meeting, ask questions, be open, and I think we can give the mic to the speakers.
Okay, hello, I'll maybe start. Thank you very much for inviting us here. We needed to a little bit regroup, so we have a slightly different group that you might have seen on the announcement. At the beginning, I'll just tell you what the agenda for today is. We'll have a very short introduction about ourselves. Then we'll talk mostly about today about machine learning engineering. So this is for us like a branch of data science, and we'll talk what it really means. And then we'll tell you how you can become a machine learning engineer. Then we'll have a small talk about careers within our group, the Applied Intelligence. And this is not only about machine learning engineer, but there are much more roles that are open, and there are much more career opportunities that we have at Accenture right now. And for, as I believe, last 15 minutes, the plan is to have a short Q&A session. I will say from the very beginning, due to personal reasons, I cannot stay till the end, so I will not be at the Q&A session, but my colleagues will be, and they will answer all of your questions. So let's go to the next slide. And a short introduction of ourselves. So as I said, my name is Tomasz Mostowski. I'm leading the Applied Intelligence group in Accenture. What the Applied Intelligence group exactly is doing, I'll tell you in a minute, but in short, we're doing data science and data engineering. And I'm with Accenture for now over 9 years. So this is quite a journey that I have been here. I never expected to be so long in consulting, but here I am. And most of my background is in the banking industry. So a lot of my work is around risk analytics and models that are to predict bad decisions for the banks, and maybe also to predict financial crime. So now over to Dominic. Dominic, we cannot hear you.
Yeah, that's the most common, I think, word of 2020 is unmute. So yeah, thanks for inviting us to this session. I'm Dominic Perykasz. I'm with Accenture for 8 years, I think now. I'm in Warsaw Applied Intelligence team. My focus is customer analytics historically. In Accenture, I'm kind of overseeing regionally data science community of practice innovation group. And yeah, that's all for my introduction, I would say. Dolly?
Okay, I'll go ahead. I didn't know that I am the oldest in this team. This is my 10th year in Accenture, and I have been recruiting for Accenture across multiple DTs. But for the past 7 years, I lead the AI recruitment for Poland. So particularly if you are looking for a job change in AI, I would be the one who would be responsible as of now. Thomas Ritter.
Hi everyone. So I'm Thomas Ritter. I'm part of Applied Intelligence in Warsaw. I've been with Accenture now for nearly 6 years. My main focus is machine learning, data science, and delivering projects within different industries like telco, banking, insurance. Yeah, with the focus on machine learning, advanced analytics, data science applications, and real world problems. So yeah, thank you.
So we already have here a path, like during 10 first years, we can become in Accenture directors, leads, and something on this level. During the 6th, we will become managers. So it's very good perspective.
Exactly.
Yeah. So let's move. Tomek? Okay. So we would like to start with a short Menti for you. So I hope you already know Menti. This is a very common tool right now. If you open on your web browser or on your phone, go to the menti.com where you can access the code.
Yeah, I will share the screen with question and code, but Thomas should please stop sharing because I cannot start.
Sure.
Okay, now you can go to menti.com and, oh, sorry. And here is the code. If you not see the code, I do it now. It's 2.
We can see it. We can
Okay.
see it at the very top of the screen. So this is fine.
We have first answer.
Okay, so we have some first answers. I think we have like 40 people on the call and we have 14 answers at the moment. But I think there's no like right or wrong answer here, of course. But you are answering about the things that are very common right now. Yeah? So the things that we are doing, big data, you know, that's, I think that the term is getting a little bit outdated because everything now is big data. So people less and less use it. but basically transforming the big amounts of data in the cloud. This is what we're doing. A lot of the things you have about credit scoring, NLP, sentiment analysis. This is things that we are using in our work as well. And we are not so much focused as the company on the computer vision and the very, I would say, deep learning. And in what we see in the real life applications, many of those things are quite narrow, and there are not so many clear use cases where you can use it. And also what we'll maybe be talking a little bit about today is many of the things have been already, I would say, commoditized. People have already plugins that you basically put your I don't know, picture or your video to the system, and it gives you the answer that you're looking for. But there are, I would say, a lot of limitations in those areas. So the places where you can use it are not so huge as you might imagine at the very beginning. I think we should be moving, or otherwise we'll be out of time. So
if I can add, like, please guys, be active, don't be afraid. It's like anonymous, there can like participate.
So what I'm always saying, you know, we are here for you and not you for us. Maybe we are not being paid to be here, but you know, it's like we are happy to share the knowledge with you. But if you do not participate, you will not probably gain so much. So the more active you are, the probably more you can get out of this this meeting. Can we go further, Tomek? Okay, so as I told you, you know, our team is applied intelligence, and basically we are focusing on analysis of data, and you can call it differently, but it's most of the things that we're doing is kind of statistics, transforming the data, getting the data in the right place. And a lot of the things, you know, like the foundations that you see at the very bottom is like data science and data engineering. And if you think about it, you know, when I did some graph about the words that people in our team use in their CVs, what they're focused on, what is their interest, it is something that you probably will find familiar with what you have seen on the graph in the Menti. And today we would like to tell you a little bit more about like something that is relatively new, but is gaining a lot of momentum, and it's very interesting also if you're thinking about your career. And this is the machine learning engineer. Because the data science and data engineering are, I would say, the foundations, but machine learning engineering is something to really keeps those wheels turning and allows the companies to scale and use their machine learning models. And if you go to the next slide, I always give, you know, this example or compare it the times that we are right now is like the area of industrialization. So here you can see on the picture, this is a Ford's factory, one of the first factories that realized how you can industrialize production of cars. And before that, a lot of the things that people were doing, they were building cars already, but they were like doing it in their small factories. They were like doing it a craft manufacturing. So every car was different, and every car was, I would say, a piece of art, but it was very costly and very lengthy to build a car like this. And now what we are seeing, actually what people are looking for in the analytics is those four words: standardization, automation, scalability, and management of those models. So the companies right now need to build their models in a scalable and automated and fast way. And what we are seeing is that, you know, when I was starting my career, a lot of the things that we were doing in data science was like this craft technology. So we're spending a lot of time on building models, focus on a problem. We had a lot of time. Those models were very costly. They were very beautiful. They were perfect. But that's not what we are looking for right now, or that's not what the business is looking for right now. They want to have models that are fast, and they want to have them tomorrow. They can't wait 6 months to get a model. And if you want to build a model, it will take you many weeks, and if not months. And the problem is that what I have seen recently is there was a survey about the companies, and to build a model, people at the moment need on average 6 weeks. This is fine. In 6 weeks, you can build a good model. But to put them into production and connect them into the systems, they need over 6 months. And if you can imagine, the world is running so fast right now that, and this is average 6 months, and there are many outliers. If you wait more than 6 months to industrialize your project, to put it into the production, sometimes it's working on the outdated data. Sometimes it's working on the outdated business models. It's working on the outdated behavior. And you can see a lot of those problems also in the COVID area, where the world changed so fast that you can't imagine. And in Poland, they open the schools, they close the schools, they open the shops, they close the shops. Every single day it works differently. And if you use the models that were developed 6 months ago, I doubt they are very useful. So what we wanted to tell you today is a part of data science, and what we are also now developing and we are building in our own teams is the machine learning engineering. So how you can help the companies to be an engineer and help them to build those models fast in an effective way. So that's for the introduction. I will now hand it over, and I will tell you a little bit more about real life examples, so how we do it.
Oh, thanks, Thomas. Thanks a lot for the intro. So now, as Thomas mentioned, I will go through and give a walkthrough of an example of how we automated the machine learning, and this is real life example for one of our telecommunication client. On how we use the automation, how we automated the entire machine learning process, the analytics process, and put that into the automated framework to bring a really, we think, good value to the client. So maybe before I jump into how the solution looked like and what was the role of the machine learning engineer in this project, I would just give a quick rundown of what was the problem. So the client basically was able to was giving their subscribers an option to purchase additional goods, services, and using the existing subscription. And while it does introduce new revenue streams for the client, it also increases the exposure of the risk, because obviously, if the clients cannot pay for whatever they purchased, then obviously this is a risk to the client. And going into a bit more details on what was exactly the problem. So the client offered their customers to purchase digital contents. So for instance, think of mobile apps, ebooks, movie subscription of Netflix, for instance, subscription of Spotify, different applications on your mobile. And usually you pay through the credit card or connected account. And in this case, the client offered their customers an ability to buy all of this content, and this would be built automatically to the total monthly bill for the pay for the postpaid customers. And obviously this is a great convenience to the client. You don't have to look for your credit card. You can just purchase whatever you want and have it billed to your subscription and just pay it off with the as part of the bill. But obviously this introduces a risk to the company, because if somebody, let's say, purchase a lot of games or purchase a lot of ebooks or whatever content and is not really able to pay it off, then obviously that's a risk and a cost to the company, because they will basically lose money because the client will not pay it off. So the idea is that somehow how do we manage that? So the idea is that that customers are assigned a certain spend limit. So each customer can spend only a certain amount, for instance, on a monthly basis for this content, to basically align the limits to the actual customer needs, and second, protect the company from the customers that potentially will not pay off their transactions and fall into the bad debt. And the whole, let's say, value optimization, or the whole problem is how do we optimize those limits in a way that once they maximize the revenue, they are also aligned well with the actual customer needs, and how do we minimize the bad debt? So basically, we have an optimization problem, and we solve that through introducing quite a robust solution that included machine learning, optimization, and visualization, and composed of the three key components. And so that's classification, optimization, visualization, and simulation. And in each of those areas, as you can see on the table, in each of those areas, the company already had some process in place on how to assign those different limits to different customers. But if we look at the classification, before we implemented the solution, this was done in a static ad hoc way. For instance, the classification, which is about classifying and understanding which customer profiles are more risky or less risky, and based on that we can then tune or understand if we can give higher or lower limits to the certain customers. Previously this was done in a static ad hoc way. It needed, for instance, data science, involvement of the data science departments that would create or build the models on an ad hoc basis in a static way. There was no automation for that. What we've done with the solution enabled for very dynamic generation of the models, of the machine learning models on most up-to-date data automatically due to the automation and help of the machine learning engineers. The second component was optimization, which is basically the optimization algorithm to recommend the best limits for each of the customer based on their characteristics, based on the on different indicators, and again from manual analysis that was previously done, sometimes experience-led limit setups. The solution enabled for fully automated optimization of the limits, recommendation of the best limits, and lastly, the visualization simulation. So once all this machinery is working, the company wants to know what's the result, what is the model logic generated, what would be the impact on the revenue if new model was introduced and productionized, what is the impact on the revenue bad debt of the new recommended limit setup, and also enable a simulation in terms of, for instance, if the client is not really agreeing with the recommendation from the machine and wants to, for instance, override or test different scenarios, then also this solution enabled that to have like a full transparency on what is recommended by the machine automation. And very quickly, just on the value, just to show that this is not something we have experimented with, that it was the proof of concept. It was fully industrialized solution, bringing very significant bad debt reduction, very high return on investment from this project, as well as importantly, very substantial reduction in the effort in terms of because the solution was automating almost the entire process of the limit setup. It basically removed or minimized to much extent the need to do any manual work or engage additional stakeholders or departments in the process. And just quickly on the architecture. So I mentioned some of the components of this solution, but the key ones were obviously the data ingestion and the processing coming from different data sources, which I will go into a bit more detail in a second. Then, which is about bringing the data from different data sources, integrating that and ingesting into a centralized place, processing, transforming in a way that can be enabled for further analytics. The customer analytical record, and the customer analytical record is the term we use, and this is you can think of it as a foundational data structure, that enables, for instance, a 360 customer view, and can be easily leveraged for any analytics, machine learning tasks, and it greatly accelerates all the analytics, data science, machine learning activities. Then the next module is machine learning classification. So this is again, I will go into a bit more detail in a second, but this is basically a module that automated generation of the machine learning or analytical models to understand the trends and predict the propensity or probability of customers going into bad debt. And the last module is optimization. So this is on top of the results from the machine learning classification. There was a custom algorithm that we implemented to recommend the best limit settings for each of the customers. And all the information flew into the visualization and simulation layer, which basically allowed for the client to see for instance, the logic of the models, the newly proposed optimization, the newly proposed limit setups, understand what is the impact on the revenue, what is the impact on the bad debt, also observe some trends, for instance, within the customer base. And importantly, this is entirely automated. So it's not that this requires much manual intervention to run the process and run the optimization, machine learning classification. It's automated and pretty much runs standalone without any manual effort needed. And again, maybe a bit of why the automation was important. So as Tomasz already mentioned, automation was important because the entire requirement from the client and the need was not to build one model, for instance, today, and then rebuild it or recalibrate it in 6 months' time or 12 months' time once it deteriorates. The client wanted like a solution that will be resilient. So for instance, if the risk profile of the customer changes in a month or 2 months' time, or there is a new segment of the customers onboarded, then the solution will pick it up automatically. The models will be rebuilt automatically. There will be no need for manual intervention or for manual build. So the solution is resilient and like prepared for anything that happens in the future. It obviously shortens time, what I call time to market. So shortens the time to deliver the outputs, data, models to the business users, because basically all of this information flow models are generated automatically. Improves the quality because of the automated nature. It minimizes for instance, the quality issues resulting from manual process or stitching data manually together, or doing some transformations of the data manually. And as I mentioned previously, it minimizes or eliminates let's say the effort / resources required to run the process. That's why it was very imperative for the client, not only to get one model today, but then in the future they will need to potentially recalibrate. They wanted to have like a solution that will be future-proof and will pick up any trends, anything that's happening with the customer base data automatically, and provide the outputs, provide the models, insights based on that automatically. And just a bit on the technical aspects, because this presentation is agnostic to the technology, and when we can think of this kind of automation and this kind of machine learning engineering, then there is now the closed set of technologies that can be used. It will really depend on the environments. It will really depend on the requirements, on what ecosystem we're working with. Maybe just importantly to call out like the key areas, which is what we call I call the car development, customer analytical record development. So basically everything that's around transforming the data, processing, advanced aggregation of the data, and again there could be various technologies, tools used, could be native database mechanisms to accelerate the data processing natively on the databases, any available tools in the analytical environments, whether it be it for instance Python libraries, be it Spark for instance, and also any use of the parallel processing, like for instance Spark, or we could think of any technologies that can be used depending on the ecosystem. The machine learning and optimization, so this could be any available libraries, be it Python libraries, any Spark, for instance, ML Spark, or any Python libraries that can be ported through Spark, for instance, if you want parallel processing. Those could be customized algorithms based in built in whatever language or whatever tools we are using. Orchestration, which is about automating the entire framework, and currently containerization, build of the pipelines, like using the QPro, for instance. This is picking up a pace, I would say, currently, but there could be standard orchestration tools used for that. Obviously, the CI/CD processes, MLOps comes into place to orchestrate the training, the deployment of the and prediction of the models, as well as last one, the visualization. So again, different visualization tools can be used, like available in whatever ecosystem we're working on. Could be visual libraries, for instance, once available in Python or in R or whatever environment we're working on. So this is to show that let's say the four key technological areas, and that let's say working as machine learning engineering on those kind of projects, it could involve different technologies or a mix of different tools and the technologies, and will depend on the requirements, on what is the best fit for the current use case, what's available, and what's strategically planned for the tools of choice. And we were speaking about the machine learning engineer and the data scientist. So maybe also a bit on what's the role of the machine learning engineer and versus the data scientist, on what is the role on this project. So because those terms are machine learning, data scientist, they are sometimes used interchangeably. So maybe just to give like an idea of what's the difference, what's at least let's say to let's say draw this line between, to give a bit of more idea what machine learning engineer does. So in terms of what on this project, for instance, or the way that this could be shaped on the project, is the data scientist, when it comes, for instance, to the problem, the data scientist analyzes the business problem, understands the value, recommends the methodologies, reviews the results with the client. So basically does a preliminary analysis, preliminary insights work, while machine learning engineer is more focused on designing of the end-to-end solution, building of the framework, understand how this will work technically, how we can industrialize those ideas, and how we can operationalize the entire let's say the entire framework. And obviously this is in cooperation with the data scientist. Also in terms of, for instance, let's say the data engineering or customer analytical analytical record development, data scientists would focus more on understanding what are the initial analytical features, so the variables that would be useful for the modeling or for the use case, analyzes the data, while machine learning engineer more focuses on ensuring that the data from the customer analytical record is feeding correctly through the pipelines, develops those pipelines, and to make sure that there is a consistency of the data and information flow from the customer analytical record through the machine learning modeling or different analytical components up to the end output, be it the end results, or be it, for instance, some APIs that serve the predictions. And I think important for for this audience is the actual modeling, so and the actual, let's say, machine learning data science work. So data scientist, I would say, is more on the experimentation side with the machine learning models, so looking at the different ways on how to tackle the use case, look at the best algorithms, best models, maybe develop some custom algorithms, recommends the best approach solutions, test those initially, and to understand what is the value, while machine learning engineer, and obviously with a close cooperation with the data scientist, is focused more on operationalizing those ideas, those algorithms, models, and also importantly looking from the, let's say, computational perspective and technical perspective, whether, for instance, whatever both will work out, whether this is for instance computationally let's say not too computationally expensive, or can it be can this be industrialized and automated. So it's more sorry, focusing on how to operationalize it, how to put it in the real life, and rather than experimenting with ideas, although it's kind of interconnected. Both data scientists, machine learning, they both work together to create the best solution that will work in some productionized state. Maybe quickly on the customer analytical record. So maybe now going a bit more into the details of the components. So just to give like an idea of the customer analytical record, so it's quite important because on this project, this formed like a foundation for the machine learning, for the analytics work, and it included different stages like ingestion, integration of the data, understanding whether creating the mechanism for detecting the data quality. We all know that the data quality is quite fundamental to getting any good results with the more advanced analytics. There was an automated data onboarding, which was basically quite a smart way of ingesting new elements of the data automatically into the solution. So for instance, if there were new types of, for instance, certain data categories, for instance, then the solution would pick them up automatically and propagate them automatically, use this information in the modeling, use this information in the optimization stage. So there was no need, for instance, for somebody to come in if there is new data categories appearing in the data, hard code those in. Now it was automated, and like there was no need for any manual intervention, and so it's quite important, obviously. interconnected with all the other components. And the customer analytical record is basically, it's like we can imagine this is a customer 360, so it gives a very comprehensive view of the customer on the and can integrate data from various different sources and provide information from different, let's say, areas, like for instance, purchase transactions, core usage. This is telco example, and customer profile, can use some external data, payments information, so all kind of data we can harvest from organization, or even from tapping into the external data sources. This is all aggregated and basically presented on the customer level, giving like a very, let's say, a lot of material to work on with the machine learning and data science, and to data mine the data. And machine learning model automation, I think many might be interested in this part. It's within the solutions. I mentioned it was important that we did not only create one model, we created the framework that enabled for the models to self-train. And obviously the solution leveraged the car. So the car was created, it was rebuilt automatically with some given frequency. And then based on that, the model, there was a process that ran the model training to rebuild or recalibrate the models on the updated data from the car. Different hyperparameters were tested, and also different types of models can be inserted easily into the framework. So basically the whole process looked like we update the car automatically based on the newest data, and then we do run a series of testing of model, of hyperparameter tuning to select the best models. But in the end, the interpretation part was also important, because the client, because of the automated nature, the client wanted to understand what's, for instance, the logic of the model, what are the trends that the machine detected that leads to the bad debt. So the client wanted some level of visibility into that, and some level of the transparency. So it was quite important to also build the layer of the visualization. So the client was quite, let's say, had enough visibility. So he was, he was quite, let's say, content with the results coming from the automated engine. And maybe just on the couple of challenges, because we did face a lot of challenges with this kind of automation, and like not even the technical ones, which obviously it was a very, let's say, very required a lot of, let's say, technical effort to create this kind of framework and this kind of solution. But maybe just a couple of challenges when we face the model automation or machine learning automation. It's, for instance, the feature selection, reduction of the dimensionality, because if we automate the models, then how do we ensure that that we're picking the right features, and also, which I will go into in a second, and also how do we let's say, keep some pool of the features that will not change drastically over time, because this might lead to for the models to get rebuilt and their logic drastically changing over time, which sometimes might not be what the client wants or what we want. I guess the one of the also challenges is how do we select the hyperparameters and the features for the automated solution. So for instance, here we initially tested some of the set of the hyperparameters to be tuned because of the computational expensiveness. We did not want to look, for instance, through all the hyperparameters of the models. So we did. So, for instance, data scientists tested which hyperparameters should be considered, and then the solution looped through this set of hyperparameters and did the hyperparameter tuning based on those. Also looking at, for instance, different subspaces of the selected initial features, also to create various different variations of the models, which leads to how to select what we call the best model or best performing model, and combined with the looping through the hyperparameters through the subspaces of the features, we used, which is I think quite popular, cross-validation to assess quality and train the models. Although in this case we did implement a bit of the custom cross-validation for this purpose, to have a bit more control over the cross-validation process. And the next step of the key one also was the optimization. So basically the machine learning models that were generated automatically, they were in the end, they were used to segment the base, because we can imagine that the machine learning models, they do predict the bad debt, but in the end we can translate them to a specific segments of varying level of bad debt based on the level, let's say based on the probability scores. So the machine learning models, they segmented the base first to give us segments of varying risk of falling into the bad debt, where there could have been additional level of the segmentation applied based on a different, let's say, features, if there was some request to apply some rules on top of that. And then for each segment, we did for each segment of the customers, there was an optimization procedure to select the best limit scenario. So we can imagine that for each customer segment, the solution selected and calculated what is the optimal setting for this segment of the customers. So what's the best value of the limit in terms of the optimizing the revenue, minimizing the bad debt, or basically minimizing the cost function. And here it was quite interesting case, because because we did also experience a lot of challenges then. And again, this was automated. So whenever the model was rebuilt, there obviously this defined a new segmentation of the customers, and then for each segment, the optimization procedure was run. So every time everything was automated. So even if the segments have changed, and they would change if the model was rebuilt, then the optimization procedure would run again automatically for each of the segment, and there could have been a lot of segments in the end, but we did face again quite a few challenges with the optimization and the automation of the optimization. So I guess one is the revenue, how to define the revenue cost function, and this one is how do we optimize based on the most up-to-date data, and this was really interesting because we did have to develop for this solution the custom algorithm to trace back the customer transactions and identify which ones can be attributed to the bad debt. We did write a custom traceback algorithm for that. So a lot of this optimization solution was actually based on this algorithm that I think was quite smart in the way that we trace the transactions that would result in the bad debt. And this was quite complex, let's say, topic. I guess I could go over for half an hour and explaining how we've done that and what was exactly the algorithm. But I think that important takeaway from that is that, and it ties with the second, the actual challenge of the selecting the algorithm on that some of the out of the box, let's say methods or algorithms, they not necessarily always work or can work, because we did, for instance, we did consider heuristic algorithms first, for instance, like genetic or simulated annealing algorithms, but they are very computationally expensive. And if we're dealing with the huge data and huge number of the segments, this is simply computationally, it's very expensive computationally. So we did develop our own grid search method that was very closely tied with the way that the backtracing algorithm was created, and was like completely custom created for this specific use case, and which it proven to be quite effective and quite fast and computationally quite robust. And it also at the same time enabled to generate all the artifacts that were needed to conduct the what I call what if analysis, which is basically allowing the client to run a scenario analysis against different limits. So let's say the automated optimization algorithm recommended that the limit for this specific segment of the customers should be X, but the client wanted to know what would be, for instance, projected revenue and bad debt if we change this limit to, I don't know, X plus 1 or Y or whatever, right? And it was important for the client because they do wanted to understand what is the business impact if they would override, for instance, the algorithm decision. And that's why we also needed to develop the custom optimization algorithm to kind of link all of this together, and at the same time make it quite computationally robust, but at the same time enable for generation of all the artifacts that are required for this what if analysis. Otherwise, if we didn't, then it could mean that if the client wanted to simulate a specific scenario, he would need to run the let's say some procedures to backtrace the transactions, etc., which were quite computationally expensive. So I guess the main takeaway is that out of the box is not always works in every case, or it works, but this might not be optimal way to do things. Maybe this would give the absolutely optimal results in terms of mathematics, statistics, but in real life, it might not be the optimal way in terms of computation and how expensive this process would be. And I guess this one is very quick on the automation and just the business perspective, because this solution was like fully automated or almost fully automated. But it's important to remember with this kind of automation of solution that there is also always a business perspective, or there is also, let's say, a human angle to it. And this becomes a very, let's say, black box sort of solution. So sometimes the clients also, or we want to understand, for instance, let's say, have transparency, visibility, and for instance, what's important to have some stability of the models, because the model logic might drift over time and it might drift significantly. And if, for instance, we were dealing with the customer analytical record where we could have thousands of different features, then it's easy to imagine that if there is even a small change in the data, then that could mean that the model will be completely rebuilt on completely different different set of potentially correlated features. So it's worth remembering that there might be a good idea to apply some model built rules that will make the model's logic more stable over time without having a negative impact on the results. So it's more easy to interpret for the end users and understand what's really happening with the customers. What are the actual trends that leads to, for instance, in this case, to bad debt, and I guess the model logic and value. So I guess it's more or less the same. It's giving some idea of what is giving the interpretation of the model logic to understand, in this case, the risk profiles, understand how the machine recommendations impact the actual value. In this case, for instance, revenue, bad debt. So to make some kind of a information layer on top of that will give a right level of the transparency to the end users, so they will be confident with what is happening in, let's say, in the black box. And I guess simulation from the business perspective also something to consider in this kind of automated solutions, is to give some freedom for the users to override the recommendations if they need to, or at least understand what's the value impact or impact if there are any manual changes would be applied to what machine is recommended, again to give a bit of more confidence to what happens, let's say, under the scenes with the whole solution. So I guess that's it. It was mostly, to sum it up, this was an example of what we have delivered for one of our clients. It's a real life example. I appreciate this was a bit on high level. There is a lot of let's say technical details for each of those components. And I think like the key takeaways is that the end-to-end automated solution we have implemented, it works, and it delivered very high value because of the automation, because of the let's say the way that the solution could leverage the up-to-date data. There wasn't manual intervention required. The models were recalibrating themselves automatically or rebuilding. So a lot of this effort was taken away. So it really delivered value to the client, and lastly, importantly, the significance of machine learning engineers. So it's of course was very important to understand the right methodologies, understand how do we develop the right algorithms, what are the initial best machine learning, let's say, methods that we would apply. How do we design the back tracing algorithm? How do we customize the optimization algorithm? But since it's all automated, then there is where the importance of the machine learning engineer that can put all of those components, elements together and make it like a working machinery, and also industrialize that. So all of those components work, they are resilient for the future, and can deliver the value long after the project is delivered. So that's it from my side. Thank you very much for listening. So now I will give it to Dominic, if that's okay, Dominic.
Maybe at this stage, maybe some people have a couple of questions already and they would like to ask.
Yeah, I have a question. Because this process is so automated, and you said that data scientists say what model to use, give guidelines, etc., etc. And so what's this data scientist's role in this automated process where models are automated, tuning is automated, optimization is automated, etc., etc.?
Yeah, so I don't want to say that data scientist doesn't have a job anymore, right? Which is not true. But I guess in this process, right, when we look at the implementation, then let's say data scientist experiments. He tests things, right? He builds like the initial like an ideas, algorithms, tests this on the historical data, for instance, works with the end user saying, this is the algorithm, this is the model we can propose, this is how it should work, right? This is what you will be getting. This is what we are projecting the revenue will be. And basically it's more like on the experimentation side, and the machine learning engineer takes it right away, industrializes that with the data scientist, and obviously that's there is some overlap with the roles, right? So there is no like a very clear distinction between the two. They work together, right? Sometimes in reality, the data scientist, machine learning engineer, it could be the same person, right? If they have the right skills. But to answer the core of the question, what the data scientist does, I guess he is not really needed anymore on the project. He goes to another project, but it's not exactly true, right? Because obviously this is automated, but there could be usually in this setup when we would industrialize, there are new use cases coming. There are some, let's say, major changes that for instance the client would want to implement. Could be new use cases, or could be like, let's say, extension of this use case that the solution doesn't cover, because this automation, it will not cover everything, right? If there is, I don't know, a need to, I don't know, build a new set of models that will predict some different behavior and or some different, completely different, let's say, targets, or I don't know, or on completely different population, then the data scientist has to step in again, because this is a new business problem, a new business case. It's not that this will solve everything and then will work forever and solve all the business cases. It's I guess it's like, yeah, the data scientist has to come back in and let's say do this work. So I would say, yeah, he's there. He might not be there, but if there is a new business case, new business problem, or extension of the existing, then I guess this is where his role is again important. I'm not saying it's not important, it's always important, but I guess in context of this project, this is how I would kind of structure that.
Okay, thank you.
Other questions?
Yes, I have a question, if no one minds. For me, the claim that you don't really have to customize your system and it's ready out of the box sounds too good to be true. Though you really have no need to customize the system for different use cases, and to what point the system can be customized?
No, I guess we always have to customize, right? The system. Even when I talked about the optimization, even this bit, right? We did develop the customized algorithm just for this specific use case. So every problem will need customization. So there is no out of the box solution that will solve all the business cases or all the business problems. This solution was tailored to the specific business case, and definitely there was a lot of customization. It's I guess we have kind of a framework that we have implemented, but it had to be customized, aligned to the specific business problem. And again, as with the case, for instance, with the optimization algorithm, even this component had to be very custom tailored to this specific requirement. So no, I mean, definitely it's there is always a high level of customization. Of course, if we facing very similar business problems somewhere else, or business case which is similar, then maybe we can reuse it more easily with the minimum level of the customization. But yeah, I don't believe that we can just plug and play things. We always need to do a groundwork before that.
So I have one more question. So what is the time between the consultations with a client and delivering this machine learning model?
It depends on how the project is constructed, right? If we, for instance, work in Agile, there is no gap because we do things in parallel. We test, right? We prototype, we test, we deliver, we experiment, we test, and we refine the solution. So I would say that's our well. Yeah, that's I guess the most effective way to do things. But even if we, let's say, not go with the agile approach, but then it's usually done in iterations. So it's difficult in those kind of problems, in my opinion, to say this is the concept, this is how we conceptualize things, and then we put them into practice and deliver them. It's usually an iterative process because we might have a concept in the beginning, work with the client, but then when we go into the implementation, then we need to implement, let's say, iteration 1, present it to the client, see what's delivered on what's in practice, how this looks like on the real data, and then we might refine it, and then we might go in a bit different direction because what we thought initially, our assumptions are not exactly correct because we did not have that clear understanding of the data, or how, I don't know, what data we can use, or how it actually works. So I would say there is no really gap in perfect setting. It should be an iterative process, and that's the most effective way.
On top of this, I would also add that it depends on how the client is advanced analytics, right? Because in this example,
I'm sorry, we can't hear you well because something wrong is with microphone. It's like breaking all the time, the voice.
Is it still
No,
challenge? Is it better?
no, it's still bad. Now you're muted, I think so.
No.
Oh, now it's great.
Now it's good.
Cool.
Great. So on the top of this, I would add that it really depends on how the client we are working with is advanced in analytics, right? Because in the example that Tomasz presented, we had maybe not from the beginning, but you had a quite defined challenge that was supposed to be addressed. Very often, we also start the interaction with the client where, everyone says like data is the oil of the 21st century and so on, and the clients really have a sizable data that they gathered, and they want to use it to gain competitive advantage, to bring in some insights, to create models that will help them optimize their business. But then in such cases, we really start the work with client from understanding through iterations and data exploration on what questions should we ask and what kind of models should we build. So not every time this kind of task is defined from the beginning. It really depends from the client.
Yeah, no, I definitely agree. So thanks, Dominic. Yes, so I guess that was more in let's say in relation to this project. We had quite a well-defined use case, but of course, if we ask more general, right, then obviously there are different types of projects, right? Sometimes things are not that well defined. Sometimes we also help defining the use cases or the business cases as well, and this will then there might be a gap, for instance, because first we conceptualize on the use cases, we help with the business case, we actually do propose, for instance, the best practices on how to implement things, or which use cases to pick, or what's the best practice in a specific industry. And obviously then there might be some gap, for instance, because before we go into delivery, because of different factors, like for instance, there needs to be environment set up, there needs to be a data ingested into the analytical environments, but it will really depend project to project. When we get into the project, we have things, let's say, quite defined. Then I would say in like when we actually in the delivery phase of the project, and I would say again that it's best to work interactively and test things with the client. And but obviously, if we look at let's say a broader perspective, then it could mean that we first do a concept and then I don't know, move to the POC, for instance, or it could really vary on the structure depending on what we are dealing with actually.
Yeah, and there is always this side that I think Tomasz Mostowski mentioned at the beginning, is that I mean, world is accelerating, and imagine that if you would like to spend a year on building the model, it would be already outdated when you deploy it, if you freeze the data set that you are working with. And I mean, the boldest example is the COVID situation, right? I mean, for many customers, for many organizations, there was such a big disturbance and the change of data patterns that happened, that most of the models were not, let's say, accurate anymore, right? So before the COVID, you had airlines that were able to very accurately predict how many people will onboard a flight on a specific route, starting from a specific date and time. Now it's not possible anymore. This needs to be rebuilt. So again, there is this factor that I would say typically you wouldn't like to build your model once it's defined longer than 3 months, maximum 6 months. But 6 months is already like a big, let's say, comfortable situation that not happens anymore, I would say.
So maybe the last question about this topic, and we can move on. And does anybody have one? Okay, so maybe let's continue.
Okay, so being conscious that we have many data scientists in participants group, I would a bit revert the question. Like from this data scientist perspective, based on the example that Tomasz presented, and also like being conscious, like from our expertise, that these situations happen more and more. This kind of projects are kind of dominating the market. I'm not talking about the industry, but this approach. What would you strike? What strikes you as a data scientist? Like, what's the high-level takeaway from this example? Don't be shy. There is no wrong answers here. Something that's impacting you as a data scientist, or maybe in the sense of the need for, let's say, extending the team skills when developing and delivering such projects. I'm a data scientist myself, so I will give my, let's say, view on this in a second, but I would be very happy if you could share your, let's say, perspective. No one?
Please, guys, don't be shy. Come on.
Yes, I mean, that's your chance to discuss. So yeah, really encourage it.
And maybe could you repeat the question again?
Yeah, I mean, from your perspective, like what is the key takeaway? Like I imagine most of our participants are like data science minded and focused. So what it means for you as a data scientist, like what type of skills you need in the team, or, you know, what it tells us, this example, how it impacts data scientists in the future. It was already kind of being touched with the first question after this.
Well, I guess that in this automation era, less and less skills that require like this modeling or hyper optimizations and tuning are needed, and more from the creative side of things, and from talking with business, with delivering ideas, prototyping, etc., etc., and maybe, I don't know, so some research development.
Very well. Yeah, I would say, I would agree. Like automation, like, I mean, even though this project and this example that we seen was a bit like customized, then the end goal was to automate it, right? So it's really needed because AI is being scaled up like across enterprises, organizations. And if we're talking about, we are not longer talking about building a one model for the company, for a single company. We're talking about building hundreds or sometimes thousands of models. So automation is required. So this is one thing. And the other and that was a very good remark. And the other thing I would say is kind of a need for talent and people who are able to, let's say, look at the data science project holistically. So, I mean, knowing that, let's say, data scientists usually focusing on once the task is kind of defined, maybe also this part of being more and more creative to drive the discussions with business. But since we are automating in more and more complex environments, thinking about cloud, for example, it's not only like only the focus on the type of modeling that we will bring in to the client to solve some questions and to address some questions. But it's also very important to look whether once we come up with this model, giving some approach, whether this can be successfully industrialized in this end-to-end pipeline of our client. Let's imagine you come up with a very sophisticated model, but then industrializing it in the whole environment is too complex, right? And the incremental gain you get is, okay, there is some incremental gain, but then the overall benefit is not exceeding the kind of a cost complexity and, let's say, the time needed to maintain this model. So this is very important, and this is also something that machine learning engineers bring to the table. So they will also make sure when working with data scientists that the whole concept is doable, right? There is one of the examples from one of the, let's say, sites that's let's say, cataloging the information about the movies, and it's recommending the movies that you would like to see. It was quite time ago, but I mean, there was like crowdsourcing initiative, this kind of a competition where the teams gathered to come up with the model that can improve what was already deployed on the client side. And there was a team, they won, there was incremental gain, but in the end, this model was never industrialized because it's complex. So that's also what's important, and machine learning engineer can help us with ensuring that we are actually going in the right direction from, let's say, end-to-end perspective. And the question is how to become machine learning engineer if one wants to become such a person. So maybe the answer is that there is no single way. If we move to the next slide. So it really depends on where you're starting from, right? Because you might be having different backgrounds. Some people can be more focused on data processing. They can be, let's say, working as data engineers, or let's say, having more like exposure when studying on, let's say, data processing part. My experience was that before I became, for example, data scientist, I was more like data engineer. I was my first job was, let's say, database programmer, and that's where I was programming ETLs and so on. Then you may have developers, statistician, data scientists, and again, other type of, let's say, specializations that you have. And if you think about becoming machine learning engineers, you need to understand where you are and then, let's say, complement it with the knowledge and skills that will allow you to, let's say, bring in this holistic approach to the project and help the project deliver, let's say, a successful AI approach. So giving this and understanding that there is so many different starting points and that there is no single path, we, let's say, in our company, if we move to the next slide, we kind of prepared a learning program for, let's say, people from different backgrounds. And the point is that you need to in each case, in each individual case, you need to understand where you're starting from, and let's say adjust to each candidates. And for this, you need, let's say, a set of trainings to complement the skills and to, let's say, come up with the cover all what's needed from machine learning engineer. And for this, you really need a set of different, let's say, trainings, which in some cases we develop our trainings, but in some cases there are already very good trainings and learning materials on the market that we recognize, and we let's say participate with a number of providers that let's say trustful and deliver quality content. And from all of these components, we come up with, let's say, the approach, say, machine learning engineer training program. This, I mean, can be visualized and explained on different starting points. If you move to the next slide, this is an example like for the developer, right? Let's say you are a developer and you would like to become machine learning engineer. So there will be definitely a couple of trainings that you would like to have. And you may, let's say, need to understand a bit more about machine learning concepts and how the machine learning models are implemented. If you didn't have exposure to microservices architecture, that's very also useful to gather this skill and, let's say, start thinking in this way, like when building the, say, more complex applications, AI applications. Sometimes it's better to divide them into, let's say, small building blocks such as microservices to, let's say, better maintain it and automate it. Then, of course, there are, since a developer can program in different languages and not necessarily their focus is on, let's say, Python or Spark, and especially application of this machine learning, then you may, for example, want to learn a bit about PySpark machine learning. What's not covered here in such case is like when someone is a developer already and build these skills, they are very good with some kind of a regime of let's say, developing an application, right? This is something, it's changing, but this is something what lacks in data science world, where we are maybe not always used from the beginning to make sure that our work is can be reproduced, and it's really well documented and can be really well, let's say, picked up by another person, so that they have the ability to understand our code and improve it when it's needed. So this is something that's already being well embraced by developer, and that's where we don't need to put too much focus on. And let's say we are talking about a couple of trainings here, but what's more important, that together and along with these trainings, we are let's say giving the opportunity to people who start as a developer to gather experience through the projects. And that's where, let's say, the people work with both teams. So these are the teams of different specialists, which include data scientists. They will include AI architects. They will include also the project managers who help to, coordinate everything. Obviously, there will be a person more on the soft skill side, business analysts who will help identify and talk with business about what we are, let's say, actually doing, and what is the business goal for the model being developed and industrialized. And let's say this is the developer angle. There can be also different angle, the data engineer, where, like, let's say, coming from my angle, being a data engineer, I had to learn a bit more about machine learning, and more than a bit more, and how to implement machine learning models before, let's say, I became a data scientist, right? But then when we're thinking about machine learning engineer, that's what's also important. Something that our developer had is the regime of building the code and the application. So you have this DevOps training that focuses on bringing in this skill to our talents that helps to understand and train how to do the continuous integration and development. So I think this is let's say this is example I would be mostly associating with on the learning path to become a machine learning engineer. And then there is another let's say example that's when you are the data scientist, and this may be, let's say, kind of for some people may be kind of strange. Why would data scientists would like to become machine learning engineers? And there is a couple of answers, right? So first of all, still there will be a need for data scientists. Still there is this, let's say, trend that everything is getting automated. So data scientists will also come to that point that they will need to fit in this overall automation trend. And also for many people, for many data scientists, after some time of the exposure to different projects, they also recognize the need to become, let's say, more advanced in this holistic view and to be able to talk about the model development and let's say the ultimate goal, like business goal, and let's say not think only from the data science perspective. So when someone advances to the data scientist position, they typically, let's say, from my perspective, my experience, they kind of choose to, let's say, specialize in specific data science area. Like we started our, let's say, webinar today. We've seen some of your focus point, NLP, right, deep learning, and risk models, and so on. But they also may want to, at some point, to go this path for the machine learning engineer, to kind of make sure that they develop something with this ultimate business goal of getting this industrialized and scaled across the enterprise. So that's I think that there's like, I think, last of these three examples. I would say that there may be different starting points, like data, not only data scientist, engineer, or developer. There may be a statistician. There can be also people who are, let's say, more on the soft skill side, where, you know, they before they become machine learning engineers, they need to do a bit more like data science and developer focused trainings. We have in our teams in Warsaw people who originally, let's say, the education path was about, for example, sociology, right? I had a colleague I've been working with was philosophy. At some point, they kind of let's say boarded on, let's say, becoming a data scientist. They did a lot of their own work to know, let's say, learn the Python and then the machine learning, and then at some point from this data scientist level, they graduated to machine learning engineer. So this is a quick summary on how you can become machine learning engineer. I'm conscious that maybe still some, let's say, a smooth line between the data scientist and machine learning engineer. Happy to answer questions about it if you have them. But other than that, we can move to the next part.
So guys, maybe somebody have questions?
Hello, one question for me. You said that you have some colleagues who are studying philosophy or more like humanistic background. Do you see the much difference between the people with background of science education path and people with this more society education path?
I think so. Yeah. I mean, there is this difference. Let's say the positive difference, right? I mean, the diversity is very needed, and really, like when you have this pod team, right? You really want to have a very like good data scientist in this. Maybe this is not a fortunate word. Like very specialized data scientist that's super knowledgeable about different machine learning models, or let's say, different ways of efficient programming like vectorization, Python, and so on. But and if they have a very good, let's say soft skill side, that's perfect, right? But coming back to your questions, the people from like more this, let's say, humanistic backgrounds, they will bring a lot of good soft skills to the table, and they will also be able, from my perspective, they will also be able to get a good dialogue with the client in cases, let's say, where you work with the clients who are less advanced in analytics field, right? They will help to find the better connection between the teams, because they have this, let's say, humanistic nature that that makes them less technical, less, you know, and they can operate in this area very comfortably. Yeah.
Okay, I see. Thanks.
Mm-hmm.
There's one more question in the chat, and
If I recommend to transfer to machine learning engineer as fast as possible,
yes,
yeah. I mean, it depends. Let's say, what do you want to focus on in your career? I would have in mind that it's good. Like, I mean, this is something that was challenging some years ago, where data scientists had to have all of these skills, visualization skills, programming skills, let's say, machine learning skills. Now, you know, there was the response from the, let's say, education. There were different programs, and such people appear on the market. And let's say you probably, many of you are like on this, let's say, programs that will give you all of these skills. And I would say that it would be very good to also be able to play machine learning engineer role. As you see on this path, it's good to be also to become a data scientist at some point, because, you know, machine learning engineer, when he, let's say, thinks about industrializing the model, he really needs to know at least at some level how different machine learning models work, what's needed as an input, what's needed as an output, what's the stability of the solution, and so on. And I would say that looking from the automation perspective, like how the AI is being scaled across different organizations, I would say becoming machine learning engineer will kind of improve your, let's say, chances on the market. Like, there is, at this point, there is relatively many data scientists when compared to machine learning engineers in, let's say, in the understanding of machine learning engineer that we present here. I think the one very striking example, I'm not sure whether this was about towards data science or about other side. Someone came up with the statistics that there is so many blog posts about data science, right? For example, like doing some models, starting from the specific point data, but there is very few, let's say, posts on feature engineering and, let's say, more advanced data engineering that is needed for developing a good model. And this gives you some, you know, perspectives on how to, let's say, gain competitive advantage on the market. If you also have the skills that are, let's say, not so widely covered on the market, you are having something, let's say, extra that can help you differentiate. Mm-hmm. Not sure if I answered the question. Yeah.
Okay, so maybe let's move on.
I pass to Dolly. Dolly.
Yes, I'm here. Okay, so hello everyone. I'm back again, and I'm sure that many of you are already excited and has gained quite a lot of information and knowledge from Thomas and from Dominic. And I'm sure that you already have some foresight about your careers, how to, or say, when to, how to go about being a data scientist or a machine learning engineer. I'm here to help you bridge how to become a data scientist engineer in AI. So I would talk about careers in applied intelligence in Accenture. Dominic has already mentioned that we hire, or say he has friends who already has or come from different background, educational background, like humanity or something. But in our AI team, majorly we hire people who are graduates or who are about to become graduate in the final semesters from study stream like computer science, physics, maths, or quantitative methods. But yes, if there are somebody who is studying or who has studied humanity or has a great inclination about becoming a data scientist and has done studies themselves or has done extra studies, definitely those are not somebody who we will decline them to be part of us. But yes, majorly the people who work in our AI team comes from this studies. And so if what we are looking at right now is people who are available to work full time or who are also students who wants to have an internship in Accenture, who are available at least 60% or 25 hours a week to work in our team. And the people we are looking at in our team are either experience in data scientists or machine learning or data engineering, or who are interested to be part of the team and to be part of such tools and technologies and the areas of interest. And other soft skills what we are looking at from you is to have good command over English communication skills, has to be a good team player, and a willingness to be part of Accenture, to learn new skills, to broaden your horizon. So those are some of the soft skills which we look at. And I will quickly touch base on the recruitment process. So whoever is in the call right now, whoever is interested, we will be sharing the email ID where you can share your CV. That is on the last slide. So starting with your application, when you apply or when you send across your CV to a certain email ID, it comes to me. And then after that, we screen the CVs accordingly. And then whoever will be selected will be sent across for an online test. This is called SHL test. It has two portions. You can also get yourself acquainted with this test because there are some dummy tests on their website which you can take before doing the actual test. And after the SHL test, we do a business case study. And further on we do, so all these steps are selecting steps. So you have to be very careful when you are given a task in the recruitment process. So every step is a selecting step. If you are not able to clear the step, then you do not proceed further. So then we have HR interview, then skill interview and confirming interview, and then move on to offer. So this is the entire recruitment process we follow. We try to complete the entire interview process in 10 to about say 15 days, depending on the availability of you. So the test and the business case takes about a week or so, and within the next week after the case study, we can complete all the interview processes. All our managers are very proactive and can be available anytime to interview you. So the fastest we can complete the process is like a week and 2-3 days, and up to about 15 days, depending on your availability. Okay, Thomas, can we go to the next slide? Okay, so what we can offer from Accenture is we can offer for a full-time employment, we can offer employment contract or the contract or mandate. And for an internship, we can offer 3 months of paid internship. And you will also have the opportunity to gain a unique experience of working in a renowned strategic business consulting company. During your employment in Accenture, you will develop and grow in your career by taking up new challenges and also learning new tools and technologies. You will also have the opportunity to work in a multinational, international environment with very young minds and also in a very positive work environment. And lastly, just to add up on this, you will have exposure when we talk about multicultural environment, international environment. Accenture is one of the largest employer in the world. We employ a little more than 500,000 people. So when you work in Accenture, there are lots of opportunities to explore. So again, is coming back to what Dominic and Thomas have touched base on. So be in applied intelligence, be it any areas you want to explore, you can be part of our AI team and explore and move to different divisions or different expertise. So that is definitely allowed within Accenture. So you do not need to be stuck at one position forever. You can explore new areas and learn new tools and technologies. Thomas, next slide, please. Okay, so this is where you have to send your CV to careers.pl@accenture.com. When you send the CV, please mention in the subject line applied intelligence event. Okay, so when you, if you don't mention this subject line, probably the person who is concerned about this inbox will not be able to know whom to send the CV to. So please make sure you mention this subject line, and all the CVs which comes to this email ID with the subject line will come to me, and I will be bridging the gap or will be adding you in our recruitment process. And further on, if you say, okay, maybe I'm not really looking for a change right now, or I would like to touch base or be part of the recruitment process in maybe 15 days or a month, please feel free to connect with me in LinkedIn. So you can note down my name. Maybe it is a bit difficult to, remember my surname. My name is easy, but the surname. So that you can reach out to me anytime, whenever you want to be part of our recruitment process. I would be happy to add you in our process. So I think that's about it from my side. Thank you so much. Please let me know if there are any questions, anything which I can answer right now.
Maybe could you please insert the link to your LinkedIn in the chat to be easier to our guests to reach to you?
Sure, I will.
And what I would also add is, if you're interested in some career advice, or you would like to know a bit more how is it to work in Accenture as a data scientist or machine learning engineer, you can also reach out to Tomasz and myself. So feel free to stay connected.
So guys, maybe some time for questions. Do you have for recruitment process, for engineering and stuff like this?
Can you hear me?
Yes.
Okay, thank you. So I was wondering, because I'm working in the Accenture right now, and I have some information that my project will decrease number of the members in it in about like 2 to 3 months. And I was wondering what are the chances to move on some data science or machine learning projects from the inside of Accenture.
So my understanding is you already work in Accenture, right? That's the question.
Yes.
Great. Yeah, we have transfers within teams in Accenture. That's not a problem. I think it requires, it requires both discussion with the current project, maybe they may not, but they may want to extend the project overall. Let's say, I don't know what's the project timeline, but other than that, it's a matter of reaching out to the colleagues in Accenture. You can also ask the manager you're working with, and for the process perspective, I think Dolly, you can also tap in.
Yes, so you can message me tomorrow, and I would be able to help you if there is anything, or I can connect you to the right person if needed.
Okay, thank you.
Maybe any other questions?
Yeah,
Yeah.
especially from colleagues who are not working in Accenture.
I have a question. Where can I find if so, any kind of examples of test tasks?
Okay, you mean the test which I mentioned in the recruitment process?
Yeah.
Okay, so this is a company who runs the tests. It is called SHL test. If you do a search, I will just see if I can just drop the link. You should be able to find the test. It is called SHL test. Okay, so there are some practices which you can do. I will just put the link here, and you can practice the practice once before doing the final test.
Okay, thank you.
I've got a couple of questions too. So first off, I would like to kind of turn the table on the technical speakers and ask you what is your favorite topic in data science? And I also have a question for Dominic specifically. What other changes do you expect to see in the data science market?
Sure. I can start with the first question about what's my favorite topic in data science. I think someone also mentioned it, graph analytics is one of more and more important part of data science. Tomasz mentioned about CAR, this customer analytics record, or let's say an analytics table. Graph analytics helps you bring a lot of context about the client that is, let's say, not easily achieved by the traditional approaches. And also you can actually apply this in lots of domains other than this example, where you have this knowledge bases that are built on graphs. That's also something very interesting. I think the other my interest in data science specifically is getting more and more about the quantum computing, which I think after the cloud and edge computing will be the next big, let's say, disruptor, where in general in area of data processing. So yeah, that's this part. Tomasz, if you would like to tap in your interests in data science.
Yeah, it's definitely. I mean, I had many interests along the time. I think what interests me now is now and always like parallelization of the computation and also the cloud, migrating to the cloud and seeing like a large scale machine learning systems working on a huge data and parallel computation. I think that's something that I find quite interesting, at least recently, and how we can really parallelize the processing on a huge data sets, and and actually start making this promise of the large scale machine learning reality, due to the availability of technologies like cloud, for instance. And I find it pretty interesting. I think it opens a lot of doors to the future.
Okay, thank you. And what would be the technologies you'd be most excited to see on a candidate's resume, for example?
when it comes to trends, I think for sure cloud, right? I mean, I think lots of us has this experience, or let's say interest in big data. And this was also, I think, one of the most frequent let's say interests at the beginning of our webinar. I would say big data, let's say in the kind of old paradigm when you had a big infrastructure on client side is a bit of a song of the past, apart from number of very specific cases. Now everything gets to the cloud. Lots of the enterprises, they transform from on-prem big data solutions to cloud because the cloud maturity is like, this is now much safer, scalable, cheaper if you do the transformation properly. So I mean that's cloud for sure. And you can think about 3 key cloud environments: GCP, Azure, and AWS. You don't have to know all of them because this is already an area of specialization. If you know one of these environments well enough to do the data science project, data transformation, this is already very good. And yeah, I mean, this is something I would look at for sure. Then again, I wouldn't mention about things like Python or R, because lots of these cloud environments give you the possibility to use different languages, right? So we are not really focusing on any specific language. From my perspective, when I was joining company 8 years ago, lots of people, they used SAS for data science. When I was joining, I was mostly let's say skilled in R, and then in a couple of years, the R was very popular language. So it's not so much about the language, but the ability to demonstrate that you already know at least one data science programming language, and that you can learn, right? Because lots of us need to learn all the time. So Thomas, what would you like to see on the candidate's resume?
On the candidate's resume, I think a lot of things, but no, I think we are open, right? As to go back to what Dali has presented. I think it's but if I were picky, right, then I would say cloud. Definitely, and obviously some, let's say, understanding of the MLOps, because I think this is something that is and it is part of machine learning engineering, let's say, area, but I think it's something that is a bit of a next step now, because a lot of companies have or are investing in the cloud or have been investing in a couple of years now. It's picking momentum, but I guess in a few years' time, this will become a must-have, and I think now it's moving the analytics into the cloud area as well, where we have MLOps and let's say and automation of the pipelines of the machine learning, of the data science, and I think that's the next big thing after migration to the clouds. And that's my feel, but don't quote me on it.
I mean, just be conscious that MLOps is kind of it's kind of relatively new, right? So this is quite picky, but it's really good.
Yes, I'm picky. Yes, but definitely we are very open. So I think it's very important that somebody really has an interest in the area as well, and I think that that skills are something that people just learn also on the job. So really, it's I think just motivation and pure and genuine interest in the area is really, I would say, on top.
But can I ask a little bit about the MLOps part? Because like from what I read a couple of weeks ago, like MLOps, it's more just an idea. Like, as you said previously, it can be done on the cloud. I don't know, with Kubeflow, for example. So what exactly do you mean by saying MLOps? This is the general idea that model will be iterated and retrained and stuff like this? Or we need to have some specific stack of tools, or Yeah, that's my question.
I can answer, Thomas. You can answer.
You can answer, Dominic.
So, I mean, my view, my angle is that it's both. It's coming both technical, like you can have MLOps on Azure, but also as a framework, right? You need to, let's say, it's good to have the mindset and experience that, it's when you develop and industrialize the model, you also need to maintain it. So MLOps, the way I understand it, MLOps is like everything from the moment the data is ingested and then passes through the data pipeline, gets transformed, and then comes, let's say, to what's so-called actual model, let's say the piece of code with these rules. And then it produces some results that need to be monitored to see whether the model is performing as we expected, and whether there needs to be some intervention. So the overall framework from my perspective, MLOps, and then it starts to this kind of a need, since the models are scaled massively across big organizations. This need is kind of being embraced by the different cloud environments providers, where they start bringing in these concepts as a, actually the actual technical solution. So this is my angle on it, but Tomasz, waiting for your view.
No, I agree. I agree. It's definitely also a set of tools and technologies. Also, this keeps changing as well. So it's difficult, for instance, to say there are some very popular technologies, and definitely there is Git, definitely there is Kubeflow, for instance. Definitely there are tools like Jenkins, etc. But for instance, this keeps on shifting as well. And if you look, there is in the future there will be a lot of native, for instance. This will be basically available natively in for instance, some cloud technologies. So again, it's like it keeps the landscape of technologies changes as well. So
Yeah, I see. Thank you.
I would also propose, Dolly, if you are seeing a CV, what's the thing that you are, let's say, expecting to see or would like to see, if you're still with us?
Yes, I'm still here.
Yeah, great.
Yeah. Okay. I think when I looked at the CV, because of my experience of hiring for AI for the past 7 years or so in Poland, the major or say percentage of the CV which goes through are those people who has format the CV properly in terms of formatting, in the sense it should not be like, out of the box beautiful or something, but at least the information which is there should be there, what you want to sell about yourself. So CV is definitely the first place which help you to be part of a recruitment process. So this should be the first place where you should write whatever you think is your best abilities or qualities. That's one. And the second one is, I'm quite open in terms of the tools and technologies, because I understand that our team hires people from different areas and different tools and technologies. So I do not say, reject somebody because he or she does not have a certain tools and technologies experience. If somebody mentions which, some technologies ever they worked on, I pass on the CVs to the hiring managers to review. So we are quite open in terms of that. And also because of the largeness of our company, even if the person is not, or his CV is not selected for AI, his CV may find somewhere in other part of Accenture. So we do not reject the CV outright. We always screen every CV and then share with the managers, and also with the feedback, move on to other DTs if they're not exactly fit for AI. So I think first is definitely writing what you want to sell yourself, so that is the most important thing.
Great, thank you, Dolly.
Thank you. That was very insightful. Are there any other questions?
I think you had the question about the trends, right? One of the questions was the trends in data science, I would say. I think that, I mean, the one that we mentioned, the cloud, which is not a trend anymore in the sense that's really like striking necessity, I would say. So it's good to go this direction also when gathering skills. I think from data science perspective, the trends, which is good to see, is AI explainability. So, you know, I mean, lots of computation power came like brought us to the point where we can launch the deep learning model and come up with some prediction which is very accurate, but sometimes nobody understands why. So there is this ongoing trend of building the tools to actually explain the models. And this one goes, let's say, along with this growing field of ethical AI, right? Because, I mean, when you explain the models, you can sometimes see that they are biased. And also when you build the models and think about gathering some data points or using the models, or even like the coming up with a business solution, it's getting more and more important to have this ethics aspect in place. And this is also already being, let's say, more and more regulated, at least in Europe, right? So ethical AI, which is good because, I mean, we don't end up with being, let's say, governed by ruthless models. And I think the next trend will be two trends will be already also aligned together. One is this edge computing, where, you know, our smartphones become more and more, let's say, strong when it comes to computing. So, you know, it's actually happening, right? You're having the models, actual models deployed onto the smartphones, right? When you have OCR, or, you know, you have some kind of picture and enhancers, and this comes along together with model security. So more and more companies are interested in understanding how to secure their models from, let's say, being reverse engineered, because sometimes let's say the effort that comes into creating such models is a big effort, and is a huge financial investment. So they want to ensure that, let's say, they can secure it and make it more proof to reverse engineering. And also there is lots of different aspects in model safety. I mean, there are some interesting cases where someone was showing that it was possible to actually identify some people based from reverse engineering some deep learning models that were processing, let's say, images or so. So this is also part of the ethical AI. I mean, not to build the models the way that can actually be reverse engineered to pinpoint some people or some data points that are, let's say, strategic for companies, or let's say decisions, the way they make their decisions. And I think the final trend, I mean, not so, I mean, popular yet, but, you know, this quantum computing, like, but imagine, you know, cloud was not so popular 4 or 5 years ago. The same can happen with quantum computing, given the maturity of this technology. So yeah, that's a kind of a summary on the trends that you asked for me. Tomasz, would you like to add something?
No, thanks. I think it was quite comprehensive, yeah.
Maybe I will ask like the last question, the summarizing question, and let's assume that a lot of participants which are here, they became machine learning engineers, and they're successful and blah blah blah. And in one moment in every like career, like in every company, I think something like this happens. Comes a client and gives you data and wants you to make a prediction or whatever. And the question is, let's say the model does not work, not because the model is not good enough, and like, I don't know, some parameters does not work, it's just because the data is not enough and it's impossible to predict. How to handle this case so it will be professional and like accurate, like, yeah, from your point of the career, how the situation should be handled?
This is a very good question, and it actually happens not maybe quite a lot, but that's where this part of defining the goal and let's say defining the modeling scope is very important. You would not like to, let's say, define very specific goals for the model, knowing that you're working with the client, which has very limited data. And this is something that needs to be managed the way that you are transparent with the client, right? So you, let's say, if let's say, imagine, I don't think it happened anytime in my career so far, but let's say, imagine someone comes, gives you lots of money for building a model on something that you consider, based on your experience a small data set. What you would like to actually do is to do a proof of concept, right? You would like to, before, let's say, saying, okay, let's get full ahead on coming with a project to do the model that we look to industrialize. Let's have a quick proof of concept and understand what can be achieved in this time with this data. Let's get some deeper dive into this data that you have, and then decide whether, let's say, we meet some minimal requirements to think about creating the actual, let's say, full model for this application, for this use case. That's how I would approach.
Yeah, I see. Thank you. It's actually, yeah, it's a good solution. Yeah, I think so. Thanks. So, Carolina, your words?
Go
on. I don't know if I have any concrete words. The one kind of intuition or things that popped into my head when we discussed the trends is that a lot of them are really deeply connected with each other. Like, you could say that both explainability and the focus on ethics, and I think the MLOps are kind of a part of a bigger trend, which I'm also really happy to see be realized, and I think it will be really interesting. I think that all the presentations were very insightful and informative and generally worthwhile, and I would like to thank you very much for your words and for your thoughts.
Happy to share, and thanks again. If you would like to, discuss a bit more with us, or you have any questions that I will appear after this call and webinar, feel free to reach us to Dolly, to Tomasz, to me, and happy to discuss and help you.
Thank you.
Definitely. Thanks for opportunity to presenting. Hopefully it was interesting, at least a bit insightful. So
yeah, and
thank you everyone for joining us and listening to us. And definitely, as we said, we are here to help you. So feel free to reach out.
And as Tomasz said, if you have any questions, just write on the chat or another group, and the answers will appear. So yeah, feel free to ask. Thank you a lot, guys, and see you soon.
Bye-bye.
Bye.
Bye.